In this lecture, we will continue Laplace transform by using arbitrary voltage source called BV source. In previous lectures, we have discussed arbitrary voltage source in time domain in transient simulation. This time, Laplace transform can be applied to the results of BV or BI signals. The Laplace transform is a transfer function of a system in S domain. The syntax for arbitrary voltage source BV source is shown here. You can see in the third line, we can add Laplace transform equations so that the Laplace transform can be applied to the result of the behavior current or voltage signals. Let's continue with an example low-pass filter that has been shown before. This is the example we have studied as a low-pass filter. The example, we have a low-pass filter by resistor and a capacitor, and in the middle we have a voltage-dependent voltage source to create a Laplace transform. So in this lecture, we use arbitrary voltage source BV to create a Laplace transform over voltage. For example, in this case, we use the value as V equals to V of V in. So this V in, we apply a Laplace transform over V in. So Laplace transform equation is written here. So this is the same equation as in the voltage-dependent voltage source E1, and we use the same parameters G0 and omega p. So this is the AC analysis result. We can see the three output signals are overlapping and identical in the body plot. These three signals are V-sense, V-sense Laplace, and VBV Laplace. So again, they are identical to each other and they have the same result. The second example is a simplified buck converter. In this example, a voltage pulses train is added at V in to a LCR network. The duty cycle of V in is 50%, period rate is 10 microsecond, frequency is 100 kHz. This example has been studied in previous lectures. So this time we add a voltage arbitrary voltage source B3. So in B3, we define the Laplace transform. So this is the equation. Basically, we add a low-pass filter with one pole at 5 kHz over the input voltage. For comparison purposes, we add a physical R and C to see if they have the same result over input voltage. In time domain, we can see the voltage of V Laplace equals to V low-pass filter in transient simulation. That means these two outputs are identical. Both of them have the input at V in, and based on that, we apply the Laplace transform to get V out. If you use mouse and right-click over B3, we can edit the Laplace equations under voltage V2. By doing so, the Laplace transform is added over arbitrary voltage B3. Just to recap, in this lecture, we show how to apply Laplace transform in an arbitrary voltage source BV. All done for this lecture. Thank you very much.